You are lost, not metaphorically lost, physically lost. You are standing in a forest you have never seen before. The trees all look the same. The sun is somewhere above you, but you cannot see it through the canopy. Which way is home? Which way is safety? Which way leads to water? For you, this is a nightmare. For your ancient ancestor, it was just another Tuesday. They walked across territories the size of entire countries without a map, without a compass, without anything you would recognize as navigation technology, and they almost never got lost. How? That is the question we are about to answer, and the answer will change how you think about your own brain. Because here is the truth, you still carry the navigation system of your ancient ancestors inside your skull. It is just dormant. You have place cells, you have grid cells, you have a hippocampus capable of building maps so detailed they would put Google Maps to shame. You just never use them. And when you understand how they used to work, you will never look at a forest the same way again. You will never look at your phone the same way either. Let us start with the hardware. In 1992, a British neuroscientist named John O'Keefe at University College, London made a discovery that would eventually win him the Nobel Prize in physiology or medicine. He was recording electrical activity from the hippocampus of a rat as the rat moved around a small room. And he noticed something strange. Certain neurons fired only when the rat was in a specific location. Move the rat a few inches to the left. Silence. Move it back to the original spot. The neuron fired again. O'Keefe called these cells place cells. Here is what this means. Inside your brain right now, you have a map, not a metaphor for a map, an actual map. Every time you enter a new space, your hippocampus builds a representation of that space using place cells. Different cells encode different locations. Together, they form a grid of position information that your brain can recall later. You have done this thousands of times without ever knowing it. Every time you walk into a new room, your brain is building a map. In Lautelin Wu, May-Britt Moser and Edvard Moser at the Kavli Institute for Systems Neuroscience in Norway discovered something even more remarkable. They found grid cells in the entorhinal cortex. These cells fire in a precise hexagonal pattern, like the intersections on a sheet of graph paper. They create a coordinate system that your brain uses to measure distance and direction. You have this right now. As you read these words, your grid cells are firing. They are tracking your position in the room. They are measuring the distance to the screen in front of you. They are building a map of your environment. You just do not notice it because for you, navigation feels effortless. But there is a catch. Your place cells and grid cells are like muscles. If you do not use them, they weaken. This is where the story of ancient human navigation begins. Consider the Tsimane people of the Bolivian Amazon. They live in small settlements scattered across the rainforest. They hunt, they fish, they gather. Their daily lives require them to navigate dense, featureless jungle, where a stranger would be lost in minutes. A Lautelin study led by Alejandro Vasquez Rossetti at University College London tested the spatial navigation abilities of the Tsimane and compared them to people from industrialized cities. The results were striking. The Tsimane performed significantly better on every spatial navigation task. Their hippocampal place cell systems were more active. Their mental maps were more precise. Their ability to encode new environments was faster. Why? Because they used it every day. Tsimane children learn to navigate the jungle before they learn to read. By the time they are teenagers, they have built mental maps of hundreds of square miles of rainforest. They know every stream, every ridge, every tree that marks a turn. They do not get lost because their brains have been trained since birth to build maps. Your brain has the same capacity. You just stopped using it. Now let us move from the hardware to the software, because ancient humans did not just have good spatial memory. They had systematic methods for reading the landscape. Take the Kalahari San Hunters of Southern Africa. These are people who can read a footprint the way you read a sentence. Tracking expert Louis Liebenberg spent decades studying them. In a Liang Isha Semmiao study published in the Journal of Experimental and Theoretical Artificial Intelligence. He made a claim that sounds unbelievable until you see the evidence. The San hunters, he argued, use the same hypothetico-deductive reasoning that modern physicists use. Here is how it works. A sand hunter sees a set of footprints in the sand. He does not just follow them. He asks questions. What animal made these prints? How fast was it moving? How long ago did it pass? Is it injured? Is it heading for water? Each question generates a hypothesis. Each new footprint is a test. The hunter forms a theory of where the animal is going and what it will do next, then checks that theory against the next set of tracks. If the tracks confirm the theory, he continues. If they contradict it, he revises. This is not simple pattern recognition. This is the scientific method applied to tracking, and it works at a level of precision that is almost impossible for a modern person to imagine. Liebenberg documented sand hunters who could identify individual animals by their footprints alone, who could tell the age of tracks down to the exact hour, who could reconstruct a sequence of events that happened at a waterhole a full day earlier just by reading the disturbed ground. Think about that the next time you struggle to find your car in a parking lot. Now scale that tracking ability up to an entire continent, because this is what the Australian Aboriginal people did. They developed a navigation system so elegant, so sophisticated, that it still works today after tens of thousands of years. They called them songlines. A songline is a route across the landscape encoded as a song. Each landmark along the route corresponds to a verse. The direction of travel is embedded in the rising and falling of the melody. The distance between landmarks is encoded in the rhythm. The song tells you where to go, how to get there, and what you will find when you arrive. Bruce Chatwin, in his Itenjo by Bashati book, The Songlines, described how Aboriginal people could sing their way across the continent. A person who had never walked a particular path before could navigate it perfectly if they knew the song. Not a rough idea, perfectly. Because the song was the map. Think about what this means. These songlines covered the entire Australian continent. Thousands of miles of trackless desert, rocky ranges, dry riverbeds, and sparse waterholes. And every inch of it was encoded in song. The songs told you where the water was. They told you which plants were edible. They told you where dangerous spirits lived. A child learned the song, sang the song, walked the song for their entire life, and when they died, they passed the song to their children. Hundreds of generations. Unbroken, no written language, no GPS, no maps, just songs. This is not primitive. This is a sophisticated information storage and retrieval system that modern GPS cannot match. GPS gives you turn-by-turn directions. Songlines gave you meaning. Now let us go to the open ocean, because the Polynesians took navigation to a level that still baffles scientists today. In Itenjobai Tishalil, a traditional Micronesian navigator named Morpiailak did something that experts had said was impossible. He navigated the Hokulea, a replica of an ancient Polynesian voyaging canoe, from Hawaii to Tahiti. That is Launten Wubai Yungli Les of open ocean. No instruments, no compass, no maps, just the stars, the waves and the wind. Morpiailak had memorized the rising and setting points of over Ibai Wushamau stars. He knew which stars passed directly over each Pacific island. He could detect the presence of land by reading wave patterns that were deflected by islands hundreds of miles away. He could sense changes in water color, the formation of clouds, the behavior of seabirds. All of these were signals. All of them told him where he was and where he needed to go. David Lewis, a New Zealand sailor and anthropologist, documented these techniques in his Ichen Jobai Tishara book We the Navigators. He showed that Polynesian navigators could maintain course accuracy within a few degrees over thousands of miles of open ocean, using nothing but their senses and their memory. Let that sink in for a moment. You get lost in a shopping mall without your phone. These people navigated the largest ocean on Earth. But here is where the story gets deeply personal, because you still have all of this inside your brain. Your hippocampus still has place cells. Your entorhinal cortex still has grid cells. Your brain can still build maps. Your brain can still read landscapes. Your brain can still encode routes as sequences. These abilities are not gone. They are not extinct. They are just buried under years of GPS dependence. Allownsenling Ishuwumiao 2D in Nature Reviews Neuroscience by Hugo Spears and Daniel Bush showed that when people from industrialized societies are trained on spatial navigation tasks, their performance improves significantly. The ability does not disappear. It just needs practice, like a muscle that has atrophied but can still be rebuilt. But here is the problem. Every time you reach for your phone to check directions, you are making that muscle weaker. Every time you let GPS navigate you, your place cells fire a little less. Your grid cells become a little less precise. Your mental map shrinks a little more. Allownsenling Arshiyimiao 2D on the neurobiology of spatial behavior in hunter-gatherer populations, published in Trends in Cognitive Sciences, found something sobering. Industrialized people have significantly smaller hippocampal maps than traditional hunter-gatherers. Not because our brains are different, because we do not use them. We traded our internal navigation system for convenience, and we did not even know we were making the trade. There is a German word that captures what we have lost: Heimat. It means the place where you belong, not just the place you live, the place your body knows, the place you could find in the dark, the place that feels like home even when everything else has changed. Ancient humans had Heimat everywhere they walked, because everywhere they walked, they built a map in their head. They did not have a home, and then, away, they had territory, they had landscape. They had a mental representation of every river bend, every rock formation, every patch of edible berries for hundreds of miles in every direction. Their entire world was Heimat. You can have that too. It takes putting the phone down and paying attention. It takes looking at the trees instead of the screen. It takes building a map instead of downloading one. Your brain already knows how to do this. You just have not asked it to. But before we get to the modern world, let us take a detour through one more ancient navigation system that most people have never heard of. The Vikings. The Vikings sailed from Scandinavia to Greenland, to Iceland, to North America. That is thousands of miles of cold, foggy North Atlantic. No clear skies for weeks. No stars, no sun. How did they do it? The answer is a piece of crystal called a sunstone. In Arinyayal, a team of researchers from Hungary tested the theoretical basis of sunstone navigation. They found that a specific type of crystal called cordierite changes color when rotated against polarized light from the sun. Even when the sun is hidden behind clouds or fog, a skilled navigator could hold up a sunstone, rotate it until the color shifted, and determine exactly where the sun was in the sky. From that single data point, they could calculate their latitude and direction. Think about the level of skill involved. You are in a small, wooden boat. The waves are high, the air is freezing, you cannot see the sun, you cannot see the stars. You have a piece of rock in your hand, and you rotate it until the light changes. And from that change, you know which way to steer, you know where you are, you know where land is. This is not magic, this is physics applied with generations of accumulated knowledge. The Vikings also used a technique called latitude sailing. They would sail to the same latitude as their destination using the sun or stars, then sail east or west along that latitude until they hit land. Simple in theory, brutally difficult in practice, because maintaining a constant latitude in the open ocean without instruments requires constant correction. Every wave pushes you off course, every current pulls you sideways. You have to feel the ocean, and the Vikings could. Let us go even further north. The Inuit of Greenland and Arctic Canada navigate across featureless ice sheets where there are no landmarks at all. No trees, no rocks, no rivers. Just white in every direction. The Inuit read the snow. They read the wind. They read the shape of drifts. They know that prevailing winds create specific patterns in the snow that persist for days or weeks. A ridge of snow tells you the direction of the last storm. A pattern of erosion tells you the prevailing wind direction. Where there is snow accumulation on one side of a pressure ridge, there is a slope. Where there is erosion, there is a drop. They also navigate using sastrugi, the ridges of hard snow formed by wind erosion. These ridges run parallel to the prevailing wind direction. An Inuit traveler can orient themselves by feeling the angle of sastrugi under their sled runners. They can navigate by the texture of the snow beneath their feet. You cannot see these patterns if you do not know what to look for. To an untrained eye, the Arctic is a blank white void. To an Inuit hunter, it is a readable surface full of directional information. Now compare that to your daily experience. You walk the same route to the same coffee shop every morning. Can you describe the shape of the buildings you pass? Can you point to the exact position of the sun when you leave your apartment? Can you find your way home from a more shunner part of town without looking at your phone? Most people cannot. Because we have outsourced our navigation to a machine. Alaunteling Isha Seamouse Tuddy from the University of California, Santa Barbara, found that people who rely on GPS have significantly worse spatial memory than those who navigate using their own sense of direction. The more you use GPS, the less your hippocampus activates. The less it activates, the less it builds maps. The less it builds maps, the smaller your mental territory becomes. Your physical world is shrinking because you stopped paying attention to it. Think about what ancient children learned. By the age of 6, a San hunter-gatherer child could identify dozens of animal tracks. By the age of 10, they could follow a wounded animal for miles across featureless savanna. By the age of 15, they could navigate across hundreds of square miles of territory without a single reference point that a modern person would recognize. These children were not geniuses. They were trained. From the moment they could walk, they were being taught to pay attention. Every walk was a lesson. Every journey was a test. Every return home was a proof that they had built the right map. Modern children are raised differently. They are taught to look at screens. They are driven everywhere. They are given devices that tell them exactly where they are and exactly where to go. Their place cells barely fire. Their grid cells barely activate. Their maps are tiny, and we call this progress. Let me be clear. This is not a Luddite rant against technology. GPS is useful. It saves time. It reduces anxiety. It helps people who truly have no sense of direction. But there is a cost, and the cost is that you are slowly losing an ability that your ancestors spent millions of years perfecting. You can get it back. It just takes effort. Start by putting the phone away for short trips. If you get lost, figure it out. Look at landmarks. Notice the position of the sun. Feel the direction of the wind. Build a map the way your ancestors did. Your brain will thank you. Your hippocampus will start firing again. Your place cells will activate. Your grid cells will recalibrate. Your mental map will expand. And one day, you might walk into a forest and realize that you are not lost. You just have not found your reference point yet. Your brain already knows the way. You just have to let it lead. There is an experiment you can try right now. Close your eyes and visualize the room you are in. Can you see the walls, the doors, the windows? Can you point in the direction of the nearest exit without opening your eyes? Try it. Really try it. Most people can do this for the room they are in. But now try the room next door. Try the floor above. Try the street outside. Try the neighborhood. Each step outward, your map gets fuzzier. Each step outward, the detail dissolves. Now imagine being a Simane hunter in the Amazon. You are standing in a clearing. Close your eyes and visualize the river 3 miles to the east. The bend in the stream where the fish gather at dawn. The fallen tree you crossed yesterday. The beehive you marked for harvest next month. The cave where your grandfather taught you to make fire. You can see it all. Every detail, every turn, every landmark. This is not because the Simane have better brains than you. They have the same brain, they just use it differently. They pay attention. They remember the details because the details matter. For you, forgetting the shape of a building costs you nothing. For them, forgetting the location of a waterhole could cost them their life. Your brain adapts to what you need. You need to remember passwords. They needed to remember landscapes. The question is not whether you can navigate like an ancient human. The question is whether you want to, because the ability is still there. But it is alive, and the moment you decide to use it again, it will wake up. Your ancestors navigated continents. You can navigate your own neighborhood. Start there, and when you do, you will understand something that most modern people never get to feel. you will understand what it really means to know where you are. Not as a dot on a screen, but as a body in a landscape, a creature of a place, a being that belongs. That is what ancient navigation was really about. It was never just getting from point A to point B. It was knowing that you belonged exactly where you were, always. You are not lost. You just stopped looking.